Yeah, so I'm Alex Lacoste, and I'm from ServiceNow. I'm a little bit of an outsider here, and I'm the last talk between you and the snack, so please bear with me. I'm going to talk about web agents and the BrowserGym ecosystem, and we're going to talk also about possible integration with NemoGym. All of the work presented here is done with my team and extensive amount of collaborators that contributed to open source code. So last year at NeurIFS, there was a keynote talk about Suitskever that was stating that 2025 will be the year of the agents. We're 1 year later. Where are the agents? Yeah, I mean, to be fair, there's a lot of demo. There's even products. They haven't been game changer, at least not to my workflow. Maybe deep research agents are fairly interesting, but what's really behind that? It's perhaps that we need to make safe, reliable, and trustable agents. So that is the mark that we need to reach. But yeah, let's start talking about basic introduction about web agents, so what it is exactly. On the right-hand side here, we have a web page where we're going to have to interact with. The task is enter the string Enola and click on the submit button. So what we're going to do to make that work, we're going to cramp the whole page and text in the LLM, and we're going to present a action space. Can be fill, click, and mouse move. This is very simplified action space just for the example. And note that there's a backend ID here. This is an ID that we injected in the HTML to have a non-ambiguous way to communicate with the LLM. Finally, we just state how we want to have the answer, and the LLM is going to respond here, fill 14, Enola, click 15. And here we go. Wow, we have an autonomous agent. It was extremely simple prompt. We can do that maybe in one afternoon of work now. I don't know. A couple of years ago, we were not expecting that we would be able to do something interesting with just simple amount of work. But, okay, what happened when we scaled that up to real-world example? Let's say I want to do my expense report, right? It's I use Concur, it's a web page. I can just log in and shoot my agent there. What's going to happen? On the left-hand side here, we have a window, the chat window where we can interact with, and on the right-hand side, things are supposed to be autonomous. And I told it that my expense report, my expense receipt were on the desktop, so I just went and I uploaded them. Okay, let's go next. See. Now it's creating the report. Of course, it's accelerated, so it's not as boring. But it's very exciting to see that it's realizing, okay, well, it's unfinished. There's a bunch of fields that need to be filled, and it's going to fill them based on knowledge-based information that I have, the receipts information, and also some common sense. And, well, it's great, except for two caveats. But for one, this was made a year and a half ago. It's a demo that we made. It was based on GPT-4, and it was definitely not at the level of doing that. So it's heavily scripted and cherry-picked to be able to make that demo. And it also 8 times speed up to make it exciting and not too boring. Nowadays, if you redo the same demo with GPT-5 or Claude, probably going to get 50%, 80% success rate without failing. It's not at the trustable level yet, but much better than it was. So now that we saw that it's easy to make an agent, we need to measure if it's good or not, and I'm going to talk about benchmarking. So when we started, the only benchmark that we had was MiniWub, a very interesting benchmark, 125 tasks, extensive amount of different widgets, but it's just a little bit too toyish for what we need to do for real-world research. So at the same time, Shuyan from CMU came out with WebArena. It's a Dockerized environment based on one-stop shop, Reddit, GitLab, and there's 800 different tasks that you can go and try your agent in there. It's a very interesting environment. And also, there was some issue with the evaluation function. Recently, a team at ServiceNow redid the whole evaluation to make sure that there was no more mistakes. It's called now WebArena Verified. At the same time that we're working on that, we were also working on a project called Web Arena, but that we obviously had to rebrand. So we called it Work Arena. And it's now that if we combine with Work Arena++, we have over 600 tasks. And the interesting part is that is built on personal developer demo instance by ServiceNow. So it's self-hosted, and you can configure them for your benchmark. So it's not like a live website that changes. It's really like a hosted by ServiceNow services that is now for Work Arena being adjusted. We're going to look at an example of level 3 tasks. They are fairly complex. And the task description is solve this ticket. So it's very generic, so it has to look into the page and understand the content of the page. And so the first step here, it has to understand that it has to go look at the protocol in the knowledge base on how to solve that task. And then it's going to have to look at some information on the dashboard. And finally, order something on the service catalog based on the information it found. It's a little promo video for our Work Arena with some agents working in it. Okay, now over time we tested a couple of different models, and clearly there's some progress happening here. With the level 1, results were fairly low in the beginning. Well, these are fairly recent model, but like the earlier model were kind of behaving similarly. We were really impressed by recent result by GPT-5. We haven't tested yet the most recent Claude model. But what was interesting, working on level 2, the tasks are much longer. It takes between 5 to 20 minutes for a human to solve them. Human get 95% accuracy. And most models were under 10% for a long time until Claude 4 came out and was like at 40%. So that was a huge jump. We were happy and surprised to see that. Then it stagnated for some time, and GPT-5 came out at 70%. So what's going on? Is it really those models are becoming more and more capable, or they are training on the benchmark or simulation of the benchmark? It's an open question. So we talked about mini-web, Work Arena, and Web Arena, and there was other benchmark, Visual Web Arena, Web Links, Web Canvas, Assistant Bench. All of these were really interesting. So what we did, we made a call for unification, and interestingly, many people responded, and we were able to gather a variety of benchmark under the same roof called BrowserGym. So this was meant to be some kind of collective work where we standardize the input and output. The action space is flexible. You can change it, but it's also somewhat standard to favor reproducibility. And we also standardize how we present HTML and accessibility tree. Together with these benchmarks, there's up to 10 benchmarks that can combine under the same roof. Now that we can benchmark, let's try to improve our agent. So first challenge that you meet with web agent is going to be the sheer number of tokens they're going to get. A single page in Work Arena can contain up to 1 million tokens. This is a log axis on the left side here. So it can contain up to 1 million tokens. LLMs are not able to digest that. Even if you trim it in some way, your LLM is rapidly going to become overwhelmed. It's going to be slow, expensive, spurious attention. So you need to do something about that. So early on, what people figured out is they can use accessibility 3. This is a web standard for visually impaired user that allows you to compress that by about 10x. So it's more like a textual description of the elements in the page with some ID allowing you to associate them. And we also inject our backend ID in there. So it brings it back to a usable way of leveraging your LLM, but it's still the World Wide Web and not every web page are accessibility ready, including mini-web. It's not, you cannot just solve it with an accessibility tree. So alternatively, what you can do, of course, I haven't talked about the image yet. You can definitely take a screenshot of your web page and directly put it in your prompt, and that's going to help. You're going to help you understand the page. But you still need to communicate which button you want to click. So is it going to be through pixel coordinates? There's set of mark that came in the past where you attribute visual label to each button, but it gets crowded very fast. It doesn't work well. So what you have to do, you have to resort back to working with pixel. So now it's starting to look more like computer use agent, where here we're using the same task. It's type Myron and click submit. So the blue dot is where the VLM decided to click. And it's typing here, and then it's going to click submit. But what's important was like having to produce these the response in pixel coordinate. It's not all LLM or all VLM that are good at that. GPT is not capable of producing accurate pixel coordinate. Claude is going to be good. So yeah, what are the trade-offs? There's pros and cons of doing so. Of course, if you work pure vision, then you just solve your context length problem. Like images are between 1,000 token to 4,000 token. As opposed to the accessibility tree wall, they can be as small, but it can also extend to all the way to 100,000 token. The software stack is much simpler if you just have to take a screenshot and send like click coordinate. So that's giving you simplification. And there's also, if you start working with Playwright and do all the accessibility extraction, there's a large amount of edge cases that are a little bit annoying to play with. And the other advantage is if you go there, then you're directly compatible with OS world, computer use agent, so you're kind of unifying the two worlds. So that's on the pro side, but there's also some cons. The accessibility tree, why it's big, it's because it's containing a lot of information that would not be on the screenshot, the occluded content. For example, there's a drop-down menu, you need to click on it to see what's underneath it, and then maybe you have to scroll that drop-down menu to search and find what you need to click on. So your episode is going to become longer because you have to do a bunch of scrolling and clicking to be able to solve it. And yeah, like I mentioned earlier, not all VLMs are capable of working with pixel coordinate. So it's trade-offs. In practice, just having your screenshot and working in pixel coordinate works well, and you can just add your accessibility tree on top of it as an extra source of information. That works well. Okay. So now that we talked about the design of your agent, the context engineering, maybe we can start thinking about fine-tuning your VLMs. So we can take the agent and send it in the environments and gather a lot of information that's going to be useful. We have over 9,000 tasks that we can use in BrowserGym, and that gives you an interesting reward signal that you can leverage in reinforcement learning environment like VRL or pipeline RL. And this is going to give you a gradient that you can use for upgrading your VLM. So if you do so, though, you have to be mindful, because you don't want to burn out all of your benchmark with the task reward. Otherwise, if you start training your VLMs and like everyone trained directly on the task reward, those benchmarks are not going to be useful for benchmarking anymore. So, but what you can do, you can leverage those environments with maybe a roaming agent that just explore in an unsupervised way, create tasks, and leverage judge model, synthetic data like we learned today. So yeah, this is very interesting. We've been doing that for some amount of time now, but we feel ready to go beyond just web agent and really explore a little bit of a broader context. So being able to do the same principle but in a broader range of environments. And this is what NVIDIA NeMo Gym is providing. Open source a couple of weeks ago. It's a platform that provides a varied environment, math, QA. You can see it as a RL hub for novel training environments or bringing existing environments. It's also scalable and synchronous. You can run it on the thousands of different servers in parallel and train your agent with that. It's also framework agnostic. You can use it with VRL or pipeline RL. So, but there's no web agent yet in that environment. So what we can do is bring BrowserGym to NemoGym. Gym. There's, can bring BrowserGym to NemoGym Gym and start leveraging for doing some training. And perhaps have even bigger reward and training bigger VLMs or LLMs. And that's going to be it for me.